The question is, consider the differential equation dy by dx is equal to 4 into x plus 2 minus y. For the initial condition y is equal to 3 at x is equal to 1, comma, the value of y at x is equal to 1.4 obtained using Euler's method with a step size of 0.2 is round off to 1 decimal place. So this is from engineering mathematics, from the topic numerical method, subtopic solution to ordinary differential equation. So the differential equation using these methods, the ordinary differential equation should be in the standard form as dy by dx is equal to f of x comma y. So this is f of x comma y. Okay. So, and initial conditions usually denoted by for x, x naught, for y, y naught. Step size usually denoted by h value. So h is equal to 0.2. Okay. So we have already the differential equation is standard form. Okay. So this is looks like standard form means dy by dx is equal to f of x comma y. So that we have f of x comma y is equal to 4 into x plus 2 minus y with initial condition y is equal to 3, x is equal to 1. Okay. Initial condition usually denoted by x naught, y naught, that is here y naught value 3, comma, x naught value 1, and step size usually denoted by h is equal to 0.2. This is step size. This is initial condition. Okay. Now, using Euler's method, we are going to find y value at x is equal to 1.4. That is y of 1.4 is equal to question mark. Okay. So by Euler's method means there are forward, backward, modified. So when the method is not mentioned, usually taking forward only. By forward, it is called explicit Euler's method. Euler's method. First, we have to find y1. If it is sufficient, then not required to find y2. Otherwise, we have to find y2. y1 is equal to, that is yi plus 1 is equal to yi plus h times f of xi comma yi. There you put I is equal to 0. You will be getting y1 is equal to y naught plus h times f of x naught comma y naught. So this is equal to y naught value 3, h value 0.2 into f times x naught y naught 1 comma 3. So how do you get this value? 3 plus 0.2 into. So in this function of x comma y, put x equal to 1, y is equal to 3. So 4 into 1 plus 2. 4 into 3, 12. 12 minus 3. So this is 4 into 3, 12 minus 9. So this is 3. 3 into 0.2, 0.6, 0.6 plus 3. Simplifies to 3.6. Okay. 3 plus 0.2, 12 minus, sorry, this y value 3. I substituted 9. 12 minus 3. So now this is 12 minus 3, 9. 9 into 0.2, 1.8. 1.8 plus 3 is 4.8. So what is y1 generally? Y value at x1. That is y of x1. What is x1? X0 plus h. So x0 already 1. H value 0.2. So this y1 is nothing but the value of y at x equal 1.2. But we have to find at x equal to 1.5. x1 is equal to x0 plus h. So one more iteration. y2 is equal to y1 plus h times f of x1 comma y1. So just now we got y1 4.8 plus h means 0.2 times function of x1 comma y1. x1 value 1.2, y1 value 4.8. So this means in the given function of x comma y, put x equal 1.2, y is equal 1.8. So 4.8 plus 0.2 into 4 times x plus 2. 1.2 plus 2, 3.2 minus 8. So this is 12.8 minus 8, 4.8. 4.8 into 0.2, 0.96. Please check. 4 into x plus 2. This is 4 into 3.2. Okay. Minus y value 4.8. y1 value. So this will be giving 12.8 minus 4.8. This case. This is 4.8. So 12.8 minus 4.8. This is 8. 8 into 0.2, 1.6. So this simplifies to 6.4. Okay. So here y2 is equal to the value of y at x2. That is y of x2. What is x2? x1 plus h. So that is 1.2 plus 0.2, 1.4, comma x2 is equal to x1 plus h. This is the reason. So therefore, the value of y at x is equal to 1.4 is 6.4. So the answer is 6.4. This is end of the question. The question is, consider the following recursive iterative scheme for different values of variable p with the initial guess x1 is equal to 1. xn plus 1 is equal to half times xn plus p by xn, n is equal to 1, 2, 3, 4, 5. For p is equal to 2, x5 is obtained to be 1.414 rounded off to 3 decimal places. For p is equal to 3, comma, x5 is obtained to be 1.732 rounded off to 3 decimal places. If p is equal to 10, the numerical value of x5 is rounded off to 3 decimal places. So this is from engineering mathematics from the topic numerical methods, solution to algebraic equations by Newton-Raphson method. Okay. The solution is actually this type of iteration formula or recursive iteration derived from Newton-Raphson method. Okay. That is from the given equation fx equal to 0. So first of all, we have to find the equation f of x equal to 0 so that we can proceed the further step by giving p is equal to 10, the numerical value of x5 is. Okay. So first we have to know that this recursive iteration scheme by Newton-Raphson method from which equation or function has been derived. So that to get that function or equation, usually we are taking xn plus 1 is equal to xn is equal to x, where that x is called root of the equation. That is, whenever the series converges, if xn plus 1 is equal to xn, okay, that is nth and n plus 1 iteration are same. When n is very large, okay, that is n tends to infinity, automatically xn plus 1, xn are equal. They are equal means they have some value. Let us take that some value is x. Okay, so given xn plus 1 is equal to half times xn plus p by xn. So this is the recursive iteration scheme. Okay, so let us say equation 1, n values 1, 2, 3, 4, 5. This is given. Okay, now let xn plus 1 is equal to xn is equal to x. Then 1 gives x is equal to half times x plus p by x. This simplifies to 2x minus x is equal to p by x. This simplifies to x square is equal to p. So this recursive iteration scheme is derived from the function or equation x square minus p is equal to 0 by Newton-Raphson method, or this is also nothing but square root of p. X is equal to square root of p. So the given recursive iteration is the iterative formula for finding the square root of a given number p by using Newton-Raphson method. If you refer Newton-Raphson method, okay. So therefore 1 is the Newton-Raphson iterative formula for finding the square root of p. P is a value. Okay. So the given is nothing but by using Newton-Raphson method, it is square root of a given number p. Okay, that iterative formula. Now here they are asking x5 when p is equal to 10. Okay, so just see root 2 value 1.414, root 3 value 1.732, like that, because this is square root p, root 10 value 2 point, etc. Okay, you will be getting. If p is equal to 10, then this x is nothing but x5, because they're asking x5. So that x5 is nothing but, I told you already, xn plus 1 x is equal to, these two are equal to some x value. Square root of 10, approximately 3.162. Okay. Square root 5 is 2.360. So square root of 10 is 3.162. Is the numerical value of x5. x5 means x only. We are treating that x1, x2, x3, so on. These are denoted by x to get the value of, that root p, which has been derived by Newton-Raphson iterative formula for finding square root of a number p. So the answer is 3.162. This is end of the question. The question says, set of observations of independent variable x and corresponding dependent variable y is given below. X, y, 4 data points given, 4 values of x, 4 values of y. Based on the data, the coefficient A of the linear regression model y is equal to a plus bx is estimated as 6.1. The coefficient B is dash. Okay, this is from engineering mathematics from the topic probability and statistics and from the regression model, linear regression. The solution is C. Direct method, indirect method. So that is a curve fitting a straight line method, and the linear equation of line of regression of y on x using that method also. So from this, n is equal to number of data points, that is number of x values, number of y values, 4. Okay, now sum of all x values, that is summation x, 5 plus 2 plus 4 plus 3, 14. Sum of all y values, 16 plus 10 plus 13 plus 12. So 26, 39, 51. Okay. Now, method 1. We know that KT means know that one of the normal equations of straight line y is equal to a plus bx is summation y is equal to n into a plus b times summation x, just by operating both sides summations. That is, summation a means a should be added itself n times. So from this summation y 51 n4 into a value 6.1 is given already, plus b times summation b means that is summation x means 14. So this is 24.4. From this b is equal to 26.6, that is 51 minus 24.4 simplifies 26.6 divided by 14. So this is equal to 1.9. 14 ones are 14, 12 is the remainder. So 12.6, put decimal point, 14 nines are 126. Okay. So b value is 1.9. Method 2. It is a long method. Okay. So given linear regression model is y is equal to a plus bx. Let us say equation. Okay. Equation of regression line of y on x is y minus y bar is equal to r times sigma y by sigma x into x minus x bar. Okay. So just express this line equation into the equation 1 form, keeping y only left side, remaining term shifted to the right side. So this can be written as the constant term is y bar minus, this is minus covariance of x comma y divided by sigma square x into x bar plus covariance of x comma y divided by sigma square x into x. Okay. So just this is 2. Comparing 1 and 2, this will gives A value and B value. Okay. From 1 and 2, we get A is equal to y bar minus covariance of x comma y divided by sigma square x, and B is equal to covariance of x comma y divided by sigma square x. Since covariance of x comma y is equal to, that is R value. R is the correlation coefficient. Okay. Since R is equal to covariance of x comma y divided by sigma x into sigma y. So if you substitute here this R here, then R sigma y by sigma x simplifies to covariance of x comma y by sigma square x. Okay. Now, how do you find covariance of xy and standard deviation? Sigma square x means standard deviation of x variable. See. Now, sum of all x square, that is summation x square. Okay. 25 plus 4 plus 16 plus 9 simplifies to 54. Next, sum of all corresponding products of x and y, products of corresponding x and y values, sum of all x y values. Okay, that is summation x y. 5 into 16 plus 2 into 10 plus 4 into 13 plus 3 into 12. This simplifies to 188. Now, mean of all x value, that is x bar 1 by n into summation x. So this is 1 by 4 into 14 is equal to 3.5. Similarly, y bar, sum of all y values, mean of y values, 1 by n summation y, that is 51 by 4 is equal to 12.75. Next, sigma square x. Okay, this is 1 by n summation x square minus x bar whole square. So this is equal to 13.5 minus 12.25 simplifies to 1.25. Just x bar we got 3.5. 3.5, 35 into 35, 1225. Okay. Summation x square value already we got 54 divided by 4. We will be getting 13.5. Okay. Now, covariance of x comma y. This is 1 by n times summation xy minus x bar into y bar. So, that is 1 by 4 into 188 minus 3.5 into 12.75. So this simplifies to 2.375. So therefore, B is equal to covariance of x comma y divided by sigma square x. So 2.375 divided by sigma square x 1.25. So please check, you will be getting 1.9. Similarly, not required to check A because we got already B in the first method 1.9. Similarly, A is equal to, you will be getting 6.1. So the answer is 1.9. This is the end of the question. The question is, the Cartesian coordinates of a point P in a right-handed coordinate system are 1, 1, 1. The transformed coordinates of P due to a 45 degrees clockwise rotation of the coordinate system about the positive x-axis are. This is from engineering mathematics, from the topic basics, that is related to geometry. The solution is, so Cartesian coordinates usually denoted by small x, small y, small z. So let x, y, z. These are the Cartesian coordinates of the point B. Already values given 1, 1, 1. Okay. Be the Cartesian coordinates of a point P. Okay. And capital X, capital Y, capital Z be the transformed coordinates of P. Transformed coordinates of P. So that means this x, y, z, the original axis rotated through an angle 45 degrees clockwise direction, clockwise rotation. Okay, so this is given clockwise. Usually that rotation, that angle denoted by theta, comma theta is equal to 45 degrees. So here the coordinate axis rotated clockwise direction through an angle theta 45 degrees, comma clockwise rotation about positive x-axis okay. Then the relationship between Cartesian coordinates and transformed coordinates, new coordinates, is given by the table which are in the matrix form. Capital X, capital Y, capital Z, a column matrix is equal to a 3 by 3 matrix, which is an orthogonal matrix here. 1, 0, 0, 1, 0, 0. Next, 0 cos theta minus sin theta. This is 0 sin theta cos theta into the given coordinates, original coordinates, Cartesian coordinates. So this is the relationship between new coordinates and old coordinates. Okay. So this is equal to theta value 45 degrees, cos 45 1 by root 2, sin 45 1 by root 2. 1, 0, 0, 0, 1 by root 2, and this becomes minus 1 by root 2, 0, 1 by root 2, and this is 1 by root 2. This xyz value already given 1, 1, 1. So this simplifies to first row into this column simplifies to 1. Second row into this column simplifies to 0. 1 by root 2 minus 1 by root 2 got cancelled. Third row into this column 1 by root 2 plus 1 by root 2. 2 by root 2 simplifies to root 2. So therefore, capital X, capital Y, capital Z is equal to 1, 0, root 2. Okay. So accordingly, the answer is option A. This is the end of the question. The question is, let maximum of A comma B Denote the maximum of two real numbers a and b. Which of the following statements is or true about the function fx is equal to f of x? Maximum of 3 minus x comma x minus 1. This is from engineering mathematics from the topic calculus, subtopic maxima minima. The solution is, and continuous differentiable also related according to the four statements. So to decide maximum of these two for given x values, okay, we don't know that x values. That means x is a real number. For some x values, this is maximum. For some other x value, this is minimum. To decide that x value, let us find the point of intersection of the functions 3 minus x and x minus 1. Okay. We know that three minus x and x minus 1, these are y values. Okay. Or you can convert y is equal to 3 minus x, because every f of x is nothing but y value, are intersecting at x is equal to 2. See that. Since 3 minus x is equal to point of intersection of two curves, you know that. Okay. When y's are equal, equate the corresponding RHS. So this simplifies to 2x is equal to 4. This simplifies to x is equal to 2. Okay. That is here x equal to 2. So for this point as base point, there are less than 2 values, equal to values, greater than 2 values. Because maximum of two functions looks like maximum of x comma minus x, so absolute value function. So therefore, f of x is equal to, if I take the values of x less than 2, for example, x is equal to 1, substitute here. 3 minus x, 2. 1 minus 1, 0. 2 comma 0 maximum means 2. That is 3 minus x. So this is equal to 3 minus x if x less than 2. Similarly, take the values of x greater than 2. One example, 3. X is equal to 3, substitute here 0, this is 2. So maximum of this is this x minus 1. Okay. X minus 1 if x is equal to x greater than 2. When x is equal to 2, both are equal. So that is 1 if x is equal to. So now regarding continuous, differentiable and minimum, maximum, we have to decide. This is called piecewise continuous functions. So whenever you have x less than 2, x greater than 2, approach by left hand limit, right hand limit, left hand derivative, right hand derivative, etc. Okay. So first check the continuity of f of x at x is equal to 2. Okay. So that is limit x tends to 2, x less than 2. This is your LH. Left hand limit at x is equal to 2. F of x. When x less than 2, what is your fx? This is equal to limit x tends to 2, 3 minus x. This is equal to 3 minus 2, 1. Or by direct substitution, less than 2 means left hand limit, left hand. Right hand means greater than. So substitute directly here also without writing this procedure. Next, RHL. Right hand limit at x is equal to 2. Okay. So limit x tends to 2. This is the notation. X greater than 2, f of x. That means limit x tends to 2. When x greater than 2, what is f of x? X minus 1. So by direct substitution, 2 minus 1 is equal to 1. And function value at x is equal to 2. That is f of 2 is also 1. So therefore, LHL is equal to RHL is equal to, okay, function value at x is equal to 2. So whenever LHL equal to RHL, then limit exists. Limit x tends to 2, f of x. So implies f of x is continuous at x is equal to 2. Similarly, because f of x is a polynomial function, for all other values of x also this is continuous. That is, and on its domain. Domain means, what is the domain of this function? Automatically for all real values. Okay. Domain means set of real numbers. Next, differentiability. So for this, what is f dash x? 3 minus x derivative minus 1. This is for all values of x less than x minus 1 derivative with respect to x is 1. This is for all x greater than 2. Just for this, find f dash x without writing limits method. 1 derivative, constant derivative 0 if x is equal to 2. Okay. So from this, when x less than 2 means that is left hand derivative value minus 1. Right hand derivative when x greater than 2 means right hand derivative. The derivative value is 1. From this, L f dash 2 not equal to R f dash 2. That is left hand derivative of f of x at x is equal to 2 not equal to right hand derivative of f of x at x equal to 2. From this, f of x is not differentiable at x is equal to 2. And moreover, we have f dash x minus 1 means less than 0 for all x. Okay. Moreover, f dash x less than 0 for all x less than 2 and f dash x greater than 0 for all x greater than 2. So what is first derivative less than 0 means? Increases. That function is increasing for all values of x less than 2. What is f dash first derivative greater than 0 means? Sorry. First derivative less than 0 means decreases. First derivative greater than 0 means increases. Fx is increasing. In this, f of x is decreasing. Okay. When first derivative less than 0, such function is decreasing. When first derivative greater than 0, such function is increasing. So this is decreasing. So for all values of x less than 2, that is up to 2, the function is decreasing, and then beyond that 2, greater than 2, the function is increasing. So they, at x is equal to 2, the function value is 1. So that is a line parallel to x-axis. So it is decreasing function value, that is f of x decreases up to a point x equal to 2 and then immediately increasing. So this is an indication of maxima, local maxima, decreasing to increasing minimum, increasing to decreasing maximum. Okay. See. Therefore, f of x has a local f of x has a local minimum at x is equal to, see, this is general graph. Say this is a point P. This is a graph, that is fx decreases up to the point P and then immediately increases. So this point is called local minimum. Similarly, increases up to a point P and then decreases. Such a point is called local maximum. First derivative method. Okay. So now see, if you are interested, graph I am drawing. Actually not required. We got the answer. Graph of fx shown below. x-axis, y-axis. Now, this is 1, marking the numbers, integers, 3, 1, 2, 3. Okay, and this is -1, negative values of y, and this is negative values of x, -1. So, what is the graph of y is equal to x minus y is equal to 3 minus x? Y is equal to 3 minus x can be expressed as intercept form x by 3 plus y by 3 is equal to 1. Am I correct? Another one is y is equal to x minus 1 can be expressed as x minus y, that is x by 1 plus y by minus 1 is equal to 1. You know how to draw these graphs, or just by finding 2 points on the on each straight line, find the corresponding 2 points x comma y values, plot that points and join that points by a straight line, because this is a first degree straight line. Okay, so just joining these two, this is 3 and 3. Okay, this is one straight line, another straight line 1 minus 1. This is, so these are intersecting at x equal to 2. Okay, this is the point. And the other one is joining 1 and minus 1. X value 1, y value minus 1. So if you take in this direction, see, joining these two, this is, so this is the point of intersection. Okay, you can extend this. This is the straight line passing through 1 minus 1, etc. Understood? So just join these two. So this equation is y is equal to 3 minus x, and this equation is y is equal to x minus 1. They are intersecting at x is equal to 2. Okay, so continuous, okay, but not differentiable, and local minimum exists, local maximum is not exist in this case. Okay, so therefore f of x is continuous on its domain, and it has a local minimum at x equal to 2. Accordingly, options A, B are the answer. This is the end of the question. The question is, consider the following expression z is equal to sin y plus it plus cos y minus it, where z, y and t are variables and I is equal to square root minus 1 is a complex number. The partial differential equation derived from the above expression is. So, this is from engineering mathematics, from the topic either calculus partial derivatives or differential equations, partial differential equations subtopic. The solution is, so from the given z, we have to derive the partial differential equation. It containing partial derivatives, second order partial derivatives, first order partial derivatives. Let us try first order partial derivatives. So given expression, that is z is equal to sin y plus it plus cos y minus it. From this, find first dou z by dou t. Here z is dependent variable, y and t are independent variables. With respect to t, partial derivative means y constant. So sine derivative, cos derivative, sine cos becomes minus sine, and it is now variable, y is constant. So it derivative with respect to t means I, where I is a constant, multiplication constant. So this will gives I times cos of y plus it, and cos derivative minus sine, and minus it derivative with respect to t is minus I. So this becomes again plus I times sine y minus it. Okay. Now dou z by dou y. With respect to y, partially means t constant. Sine derivative cos derivative minus sine, y derivative 1. So you will be getting cos of y plus it minus sine of y minus it. So from this dou z by dou t, dou z by dou y, I cannot eliminate this cos and sine. That means will not gives. Here there is a plus along with even I common, there is a plus between cos and sine, but here minus. So there is no relation between these two partial derivatives according to the options. Let us try second order partial derivatives. Now dou square z by dou t square. That is, for this dou z by dou t, differentiate partially with respect to t, automatically y constant. So one more I multiplying, but cos derivative minus sine. So minus I square sine y plus it, sine derivative cos, but here minus it derivative minus I. So this becomes minus I square cos y minus it. So I square value minus 1. So this is finally, I can write sine y plus it plus cos y plus it. So in option A, option B, second order derivative, partial derivative with respect to t and with respect to y is there. Let us say this is 1. And dou square z by dou y square. So for this dou z by dou y, one more partial derivative with respect to y, t constant, y derivative 1, cos derivative minus sine. So minus sine of y plus it, and sine derivative cos minus cos of y minus it. Okay. So here I can take minus common, sine of y plus it plus cos of y minus it. So this nothing but minus dou square z by dou t square from equation 1. This is dou square z by dou t square. So from this can be written as dou square z by dou t square plus dou square z by dou y square is equal to 0. Is the required partial differential equation. Required means because this is one of the options in A. Okay. So that understood is the PDE derived from the given expression. Okay. Derived from given expression. So accordingly, answer is option A. This is end of the question. The question is, for the equation dqy by dx cube plus x into dy by dx whole to the power 3 by 2 plus x square y is equal to 0. The correct description is ABCD given. So this is from engineering mathematics from the topic differential equation, subtopic basics, order and degree. So you know that order of a differential equation is order of the highest order derivative, and the power of the highest order derivative is called the degree of a differential equation. provided the differential equation is free from radicals and fractions as far as the derivatives are concerned. That is, whenever the differential equations, the given differential equation is a polynomial equation in all the derivatives, then only degree is defined. For order, there is no restriction. Highest order derivative is the order. So, solution. Order is equal to order of the highest order derivative. In the differential, this is third order derivative, this is first order derivative. So order is equal to 3. For finding degree, we have to eliminate the radical 3 by 2. So for which this can be written as differential equation. DE stands for differential equation, can be written as d cube y by dx cube plus x square y is equal to x times dy by dx whole to the power 3 by 2 with minus. So shift that middle term to the right side. Now squaring both sides, we get d cube y by dx cube plus x square y whole cube plus x square y whole cube squaring. This is square only. Okay. So it is not 3, it is square. Whole square is equal to right side x square dy by dx whole power 3 by 2 whole square. 2 and 1 by 2 got cancelled. You will be getting whole cube. So this is a polynomial equation in all the derivatives. When we expand a plus b whole square, all the derivatives should be in the form of polynomial equation. Polynomial form, polynomial function is a polynomial equation in the derivatives What is polynomial equation in the derivatives means to find the degree, all the derivatives having the power, a natural number. Okay. That means the differential equation is free from radicals and fractions as far as the derivatives are concerned. Okay. Understood or not? The differential equation is free from radicals and fractions as far as all the derivatives. So, dy by dx whole cube. 3 is a polynomial natural number. D cube by dx cube whole square after expanding. That power 2 is a natural number. So, all the derivatives having power natural number, that is called polynomial function or polynomial equation. Okay. Some people, this is called the differential equation has been expressed free from radicals and fractions as far as the derivative is concerned, then only we can find the degree. So, therefore, degree, that is power of the highest order derivative. Power of the highest ordered derivative. So, this is equal to now 2. So, this is all the derivatives in the given differential equation are ordinary derivatives. dy by dx, d cube by dx cube, ordinary derivatives. So, this is an ordinary differential equation of order 3 and degree 2. Accordingly, the option is A. Okay. So, this is the end of the question. The question is, the Fourier cosine series of a function is given by f of x is equal to summation n is equal to 0 to infinity fn times cos nx. For f of x is equal to cos power 4x. This is f of x. The numerical value of f4 plus f5 is round off to 3 decimal places. This is from engineering mathematics from the topic Fourier series, that is subtopic Fourier series, topic calculus. The solution is, so this is a cosine series. Okay, all terms are expanding. The summation you'll be getting all cosine terms. But here interval is not mentioned. So this is a tricky idea for the given function. This is a tricky problem. What is the tricky problem is? So here fx given how much? Cos power 4x. Okay. So this has to be expressed cos 2x, cos 3x, cos 4x, etc. That is, we have to eliminate the power 4 by using the trigonometric formula 2 cos square a. So 2 cos square a formula is 1 plus cos 2a by 2. This is whole square. Since 2 cos square a is equal to 1 plus cos 2a. So now 1 by 2 whole square 1 by 4 expanding by a plus b whole square 1 plus 2 cos 2x plus b square cos square 2x. This is again looks like as above 2 cos square a. There is no multiplying by 2. That means we have to write after using that formula whole divided by 2. 1 by 4 1 plus 2 cos 2x, or you can write here all are multiplying directly. Multiply all the three terms by 1 by 4. Then again use 2 cos square a formula. One by 4 into 1 by 4 plus 2 by 4 means 1 by 2 into cos 2x plus 1 by 4 into cos square 2x. I can write again 1 plus cos 2a 2 into 2x 4x whole divided by 2. So here you will be getting 1 by 4 plus 1 by 8 plus 1 by 2 cos 2x plus 1 by 8 cos 4x. Okay. Now this is 3 by 8 plus 1 by 2 cos 2x plus 1 by 8 cos 4x. This is your fx. Okay. Fourier cosine given Fourier cosine series is f of x is equal to summation n is equal to 0 to infinity fn cos nx. This f of x I can use the above 1 by 8, 3 by 8 plus 1 by 2 cos 2x plus 1 by 8 cos 4x, and expand the summation by giving 1 by 1 value for n, f0 cos 0, next f1 cos 2x cos 1x by putting n1, f2 cos 2x, next f3 cos 3x plus f4 cos 4x plus f5 cos 5x plus so on. So equating like terms implies the constant term f0 is equal to 3 by 8, f2 is equal to 1 by 2, f4 is equal to 1 by 8, f5 is equal to 0. In the left side there is no cos 5x terms, So here equating like terms. That is comparing the coefficients of cosine terms on both sides. So here not required to write all these f0 and f2 also. Am I correct or not? Yes, see this. This is also not required. Okay, because the question relate only f4 and f5. So equating like terms, we get, so this is 3 by 8. Okay, so cos 4x coefficient is 1 by 8. Here cos 4x coefficient is f4. And on the right side, cos 5x coefficient is f5. Here it was absent. I can write 0 into. Okay, remaining all terms 0. Okay, therefore, the numerical value of f4 plus f5 is nothing but 1 by 8 approximately, that is 0.125. So the answer is 0.125. This is the end of the question. The question is, the matrix M is defined as M is equal to 1, 3, 4, 2 and has eigenvalues 5 and minus 2. The matrix Q is formed as Q is equal to M cube minus 4M square minus 2M. Which of the following are the eigenvalues of the matrix Q? So this is from engineering mathematics, from the topic linear algebra, subtopic eigenvalues, solution. So let lambda be an eigenvalue of matrix M. MAT means matrix. Then the eigenvalue of matrix Q is equal to M cube minus 4M square minus 2M is, this is a polynomial f of M. Is a polynomial in the matrix M. So whenever a matrix having eigenvalue lambda, then the polynomial function f of A or f of M has an eigenvalue f of lambda. Just substitute lambda here in place of M. Lambda cube minus 4 lambda square minus 2 lambda. Okay, using properties of eigenvalues. Since properties of eigenvalue. Okay, now for a 2 by 2 matrix M, automatically Q is also 2 by 2 matrix. So it has given 2 eigenvalues. For each given lambda, we have to find the corresponding eigenvalue of the matrix Q. Implies lambda cube minus 4 lambda square minus 2 lambda is equal to 5 cube 125 minus 4 into 5 square 100 minus 2 into 5 minus 10. So this is 50. For another value, lambda is equal to minus 2 implies lambda cube minus 4 lambda square minus 2 lambda is equal to minus 2 cube minus 8 minus 4 into plus 4 minus 16 and minus 2 into minus 2 plus 4. So this is minus 20. Okay. So these two are the eigenvalues. That is, E values means eigenvalues of matrix Q. Okay. So accordingly, option A, option C. So this is either multi-solution question, MSQ, okay, or more than one option satisfying this. So the answer is A and C. This is end of the question.